maybe somewhere up at the top here, just write notes so you know what this page is about. I don't think it's a worksheet or something, okay? Okay, so our learning goal today says I can translate word sentences into algebraic equations. So we're going to be working with algebra today. Algebra is very abstract. In other words, it's sometimes hard to wrap your head around all those unknowns and be able to think about them algebraically. So you do have to be tuned in, asking questions if you're not understanding, and making sure that you've got your thinking caps on. So, first thing we're going to do here is it says write variables for each of the word statements. So in other words, we're going to figure out what are the unknowns in the situation, and we're going to pick a variable for each of the unknowns, a different variable for each of them. Then we're going to write an algebraic statement, which is going to be called an equation, okay? So here's a model. Let's tear this one apart. They've already done this one for us. The Hoffman Building is 4 stories taller than the McCain Building. Write an algebraic statement about the height of the Hoffman Building. So did they tell us how tall the Hoffman Building is? No, they didn't give us that. That's an unknown, isn't it? Did they tell us how tall the McCain Building is? No, they didn't really tell us how tall it is either. That's another unknown, isn't it? So notice that's what they gave for, it says let x equal. So when they tell you to describe the variables, this is what you have to do. Let x equal, and you get to pick which one are you going to call which. X is going to be the height of the McCain Building according to the person who chose for this one. And Y is going to be the height of the Hoffman Building. Those are our 2 unknowns for which now we're going to write an algebraic statement, also known as an equation, and here's their algebraic statement right here. Y equals x plus 4. Well, where did they get that from? Where did that come from? Caden?
Y equals x plus 4 because the Hoffman Building is 4 stories higher than the McCain Building.
Yeah, the Hoffman Building. So right here it says the Hoffman Building, and then it says is 4 stories taller. That means more, right? Taller would be higher, more than the McCain Building. So basically they've said that the Hoffman Building, so let's put off to the side here that the equation is set equal to y. Would you write that off to the side in your notes, please? And let's figure out why did they choose to let y be the variable it was set equal to. Well, here's the reason why they set it equal to y. It says right here, write an algebraic statement about the height of the Hoffman Building. About the height of the Hoffman Building. In other words, describe the height of the Hoffman Building. So y equals, here's how we can get the height of the Hoffman Building. We add 4 to the height of the other building, the McCain Building, to x. So x plus 4, or it could be written 4 plus x. Why can we write it x plus 4, or we can write it 4 plus x? What is that property called again that allows us to mix up the order in addition? Starts with a C. Commutative property allows us, so x plus 4 really means the same thing as 4 plus x. Okay, so if you would have the 4 first, it wouldn't be wrong. Okay, so let's go now, let's try to see if we can do it. Sam is 3 years older than his brother Terrell. Write an algebraic statement that describes Sam's age. Did they tell us how old Sam is? No. Did they tell us how old Terrell is? No. What did they tell us? Sam is the older one, and he's 3 years older than his brother, right? Okay, so let's let x equal what? What can we let x equal? One of our unknowns. How old Sam is. Okay, so Sam's age. We don't know how old Sam is. Variables represent unknowns. Katie,
Terrell's age.
what's Terrell's age going to be? The Y? Okay, so you want Y to be Terrell's age, okay. Our other unknown. We don't know how old Terrell is. Now, notice they didn't ask us to find out how old they are, did they? What did they ask us to do? Write an algebraic statement that describes, let's circle this, that describes Sam's age. What variable did we call Sam's age? X. Okay, so that one's X. So that would mean maybe we could try, see if it's possible to write an algebraic statement that is X equals then. Sam's age is equal to what? What could we do? If Sam is 3 years older than his brother Terrell, how could we finish this algebraic statement? Sam? Y plus 3. In other words, add 3 to Terrell's age. Add 3 to Terrell's age. Okay, so it's going to be important that we can set up an algebraic statement that's going to make sense. So let's check it out. Let's see if it check to see if it works. Let's check. Let's check it. Let's see how good we are. Let's make up a situation. Let's figure out, let's work with, if we're supposed to be, a statement that represents Sam's age, let's make up an age for Terrell. How old do you want Terrell to be? Wait.
12.
Okay, so Terrell is 12. That means Y equals 12, right? So to figure out how old Sam is, we would use our algebraic statement that says X is equal to 12 plus 3. So when we add 12 and 3 together, we'll get our X value, which is what?
15.
15. So that's whose age?
Same.
Sam. That's how old Sam is. So we're just making up a situation to see if we have a good statement, if our statement gets us good results. So if Terrell is 12, should Sam be 15?
Yes.
Yeah, because he's supposed to be what? He's supposed to be 3 years older. So he does turn out to be 3 years older with our algebraic statement, with our equation. So oftentimes when you're setting up these equations or you're picking from a multiple choice answer bank on a quiz for the right equation, you need to check the equation out. Make up a situation if you have to and say, would this make sense if these are the numbers that got substituted into it? Okay? Questions? Okay, go ahead. I'm going to give you a minute to look at the next one and see if you can decide what the two unknowns are, how we could describe our variables. So what are our unknowns in this one? What's one of the unknowns, Dan? Okay, so that's all one, or is that two different ones? Oh, so the sunset, what about the sunset? How long it takes to set, or what? No, what's the unknown? What do we not know? We don't know. What about June sunset? And what about December sunset? Don't we know? Ikea, can you add on?
I don't know what time the sunset.
Yeah, we don't know the time, so that's an important part of it too. We can't just say June sunset, so we're going to say June. Which one do you want to be June BX? Danny, you get to pick. June, okay, so June's, we're going to show June's sunset, but that wouldn't be enough. So we're going to add on the word time. What about the sunset? What time does it set? And then if June gets X, then December gets Y. Okay, so December's sunset time. Okay, now I'd like you to give a try at how do you think that equation then should be written for that one. Okay, anybody got an idea what they think might work for this one? I'm not going to take Halloween away if you're wrong. Okay. Wait.
X equals y plus 3.
X
Or minus 3.
Okay, so y minus 3?
No, it's plus 3.
Okay, which one do you want? Make up your mind here, sir.
Plus.
Plus. Okay. How can we check to see if this is a good equation? How can we check to see if this is a good equation? Because even Wade was a little bit not sure. He wasn't sure if he should subtract or if he should add. What do you think we could do to check it? So let's do it. Check it. What did we do last time? We picked something for which variable? Didn't we pick for the y? Okay, so let's pick a time that maybe the sun would set in December. What time do you think, Katie?
2
No, a time.
Oh,
A time of the day. 10 at night? That doesn't seem very reasonable. 10 o'clock at night in North Dakota, maybe somewhere it is. Let's pretend we're in North Dakota. Does it say where we are, by the way? No. Let's pretend we're in North Dakota then.
6:37.
Okay, 6:37 o'clock. Oh, these guys don't want to agree with you yet. Kira?
8.
8? Oh, Harley. It's more like 5. Probably, you know what? Let's do some compromising. Let's just say 6 o'clock, okay? So let's say December sunset is 6 p.m. That means y equals 6, okay? That means y equals 6. Does the PM matter in our equation? No, it matters in our world. We know that the sun doesn't set in AM, so that's... So now we would say, okay, well, if our equation is a good equation, when we put 6 in for y, what do we get for x? What do we get? 9. So that would really be 9 what?
9 o'clock.
9 o'clock at night, right? So this is June's sunset. So June's sunset time, oh no, we don't have to put time, we'll just say is 9 p.m. Okay, does that seem reasonable?
Yes.
Why? Why does that seem reasonable? Don't move on without me. Why does that seem reasonable?
Because it's at night.
Well, because it's at night, that's true, yeah. We're still at night.
3 hours later.
And it says in June, the sun sets about 3 hours later. So in June, it is 9 p.m. 3 hours later than 6 p.m.?
Yeah.
Yes. So if we would have subtracted, would it have worked? 6 take away 3, that would have said that the sun is setting at 3 p.m. in June. 3 hours earlier, not later. Okay, so we have to, so again, you know what, don't be just happy that you know how to put an equal sign and some variables and some numbers together. You've got to learn right away, or we won't survive next year in algebra if we don't learn how to write algebraic equations this year and write ones that make sense, okay? Anybody have questions? Okay, then moving on, we got a couple more we're gonna practice. 2 women are rock climbing. The first climber climber is always 10 feet higher than the second climber as they go up the mountain. Write an algebraic statement that describes the height of the first climber. Okay, what don't we know this time? What don't we know? What are our unknowns that our variables could describe? What's one of them? What's one of them? Harley, what's one?
We don't know what exactly height what they are, like what height they're exactly at right
Who's they?
now. The climbers.
Okay, so one of them is,
10 feet.
did they give them a name?
No,
No.
first climbers 10 feet high.
Okay, so, yeah, but that isn't our unknown. The fact that the first climber is 10 feet higher than the other one, that is not our unknown. What is our unknown, Sam?
How high they climb.
Okay, so the height of the
Second climb.
first climber, height of first climber, nameless climber, just first,
Maybe his name is first.
maybe. And then the height of the
Second.
second climber would be our other unknown. In our unknowns, the 10 has nothing to do with it. We don't know how high up the first climber is. We don't know how high up the second climber is. But what we do know is that the first climber is always 10 feet higher than the second climber. The first climber is always 10 feet higher than the second climber. Write an equation for that. Okay, who's got one to share with us? No, I need to see a new hand in here. I've got all kinds of other people that haven't had a word to say yet today. Waiting on all you people that haven't had a voice yet today. Okay, if we're not right. Cheyenne. Okay. X, the height of the first climber, is equal to Y, the height of the second climber, add 10 to it. Okay, how many of you want to agree with Cheyenne? I think this looks like a good one. Okay, is it because we've been adding all along and that's why we should add? No, not necessarily. So what are we going to do? What are we going to do? Check it. We're going to make up our own situation. So, yeah, let's remember they want us to figure out a statement that would help us find the first climber's height. So let's make up a height for the second climber. How high up the mountain is the second climber? Kira?
20.
20 feet? Okay, so it's because it's measured in feet, isn't it? Okay, so the second climber is at 20 feet. We can abbreviate feet FT. Second climber is at 20 feet. Second climber is 20 feet up the mountain. So that means what equals 20? Y equals 20. The second climber's height is our Y. So that means if we substitute 20 into our equation for the Y, that will give us how high up the first climber is. How high up is the first climber then? 30. Okay. And that would be feet, wouldn't it? So this is the first climber. Did our equation get us a good answer? Because remember, what did it say? Yeah, the first climber, how high up are they? So, and they're supposed to be how, compared to the second climber, what are they supposed to be? 10 feet. 10 feet what?
Higher.
Higher. Is 30 10 feet higher than 20?
Yes.
Yes. So we have a good equation. Okay. So again, maybe you come up with a different way to write the equation. Maybe you give the second climber the x value and the first climber the y value. whatever way we do it, our equation better makes sense to the situation and how you describe the variables, okay? Okay, we got one more to do, and this is kind of a tricky one, so let's see how we do on this one. There are 4 times as many students as adults on a field trip. So tell me, what would that look like if there's 4 times as many students as adults on a field trip? What would that look like? What do you mean? Like, can somebody describe maybe a field trip and the number of people going?
Chaos.
Not chaos, but you know what I mean. What would that look like? 4 times as many students as adults. Okay, then let me see if you can figure out the comparison between students and adults in this classroom. What's the comparison of students to adults in this classroom? There's 15 of you, by the way, I'll help you out there.
15 to 3.
Okay, tell me what that means. What does 15 to 3 mean?
5 times.
5 times what?
30.
No.
5 times the amount of adults.
5 times,
3.
no, 5 times what? Kira?
5 times as many students there are teachers.
Yeah, there's 5 times as many students in here as there are adults. There are 5 times as many students, right? As there are adults. There's more students than adults. 5 times as many of you guys as there are adults. Okay, so this one says there's 4 times as many students as adults on a field trip. Write an algebraic statement that describes the number of adults on the field trip. So what are our 2 unknowns, first of all? What's one of our unknowns? What's one of them? And what's one of them? Come to her rescue, Kelia. Oh, we're going to have to dig deeper for rescue. Kaylee, can you come to the rescue? Or any of you, can you speak up now? Tyler, can you come to the rescue? Oh yeah, number of adults, that would work. Okay. We don't know how many adults there are. It doesn't tell us how many there are. What's the other unknown then? Class?
Number of children.
Number of students. Okay, now we gotta come up with an equation. What do you think we could use? Let's try it. Let's do something. What do you think we could write? There are 4 times as many students as adults on the field trip. Let's go back to that there's 5 times as many students in here as there are adults. How would you figure out how many adults there are if you know that there are 5 times as many of you and there's 15 of you? What would you have to do? Subtract 15, take away 5. Sylvia? Divide. 15 divided by 5. And then what is that? Oh, and there's 3 adults in here. So I wonder what we could do for this one. There's 4 times as many students as adults. What do you think we could do? Somebody throw one out, we'll try it, see if it works. I'm not giving it away. Maybe I'm not as smart as you today. Cheyenne thinks she has one for us. What do you think it is, Cheyenne?
Y equals 4 times X.
Okay. Let's see if that works, okay? So if that one works, then with it, on this one, we'll see if it makes sense to this problem. It says, if there are 8 adults on the field trip, how many students are there? Okay, so let's go over here, and why don't you just let me do this, okay? Just watch me. Let's just see if it works out. Then we don't have a bunch of erasing to do in case we're wrong. We'll just keep trying things till we're right. So if there are 8 adults on the field trip, where should the 8 go in? Should it go in for the X or for the Y in our equation? It says X. Number of adults is X. So that means we're going to put 8 in for X to find the number of students. So Y equals what? What does Y equal then?
32.
32. Okay? Does it make sense that there would be 32 students? Remember, these are students. Y is the number of students. So if there are 4 times as many students as adults on the field trip, do you think there should be 32 students? Yeah. Well, then I think this looks like a pretty good equation. So now you can write down all that work I just did. We can go with it. And we'll fill in the blank. We'll say there are 32 students. Now, notice what, back up here, if you look at a copy of the completed notes on my webpage, I did not write the equation this way because it says an algebraic statement that describes the number of adults on the field trip. What is this describing? The number of students, okay? So, can we use this one though? Yeah, it works. But if we were going to do it, let's think about, I want us to come down here and let's put a big or. Yeah, I don't know why you guys are putting things away. Where are you going? Let's put describes number, we'll abbreviate that, of students. Let's write an equation that would do it. The one we wrote describes it as the number of adults. How would we do it as the number of students? Well, our students are Y, so our equation has to start with Y. What would we have to do instead then if we were going to have our equation set equal to the number of students instead of the number of adults? What's the undoing of multiplication? Dividing. What do you think we could do? We could take the number of adults and divide it by 4. Can we do that? You think that'll work? Oh, wait a minute. We had it set equal to Y, didn't we?
Yeah.
All along. Why did somebody say that to me?
We were just trying to figure it out.
We had it set equal to Y all along. I did not need to do it. This is going to change. You know what? And since we're running out of time, just erase all that. It's okay. We already had it describing the number of adults. Y equals, Y is the number of adults in or X is the number of adults. No, we didn't really. We had it as students. Okay, it's okay. We're just going to leave it. We're just going to leave it. We're not going to worry about it. Okay,